This is question number 9. We're told the equation for quantity k plus 3 x squared plus 6x plus k equals 5, where k is a constant, has two distinct real solutions for x. In part A, we need to show that k satisfies k squared minus 2k minus 24 is less than 0. This question carries 4 marks. If we have a quadratic equation in the form ax squared plus bx plus c equals 0, the discriminant b squared minus 4ac will be greater than 0 for distinct real roots. And that's the first thing I'm going to write in my answer. So for distinct real root or real solutions. So the first thing I need to do is put this quadratic in the form ax squared plus bx plus c is equal to 0. So we'll have the quantity k plus 3 x squared. We'll have plus 6x, and at this stage I'm going to subtract 5 from both sides and write this as k minus 5 is equal to 0. We can see from this that the value of a is k plus 3, the value of b is going to be 6, and the value of c is going to be k minus 5. So using the discriminant b squared minus 4ac, we can say that 6 squared minus 4 multiplied by a, which is k plus 3, multiplied by k minus 5 must be greater than 0. At this stage, we've got a couple of different choices. What I'm going to do is add this quantity to both sides. So I'm going to write this now as 36 is going to be greater than 4 multiplied by k plus 3 multiplied by k minus 5. I can divide both sides of this inequality by 4. That's going to give me now that 9 is greater than k plus 3 multiplied by k minus 5. If we expand the brackets, 9 will be greater than k squared. We're going to have minus 5k plus 3k minus 15. I'm now going to subtract 9 from both sides and tidy this up. We'll have k squared minus 2k, we got minus 15 minus 9, which is minus 24. So we've done this, and of course we could write it the other way. We could write it now that k squared minus 2k minus 24 is going to be less than 0. So that's the first part done. You can argue that that could be done slightly quicker. It's entirely up to you. I just want to ensure that I'm going to get the full 4 marks, and I've done it step by step. In part B, it says, hence find the set of possible values of k. The question carries 3 marks. So what we're looking at is a quadratic inequality. We can go ahead and factor that. We would have now k minus 6 multiplied by k plus 4 is less than 0. So if we consider the critical values, we'd have now k is equal to 6, and we'd have k is equal to minus 4. These are our critical values. We're going to go ahead now and plot these with a simple parabola and consider now the set of possible values. So if we look at the critical values, we've got now minus 4 and we've got positive 6. So if I sketch the parabola looks something like so. We'll come round, we'll come back up and through this point here. We know that this is 0. We've got here 6 and we've got here now minus 4. We're interested when this is going to be less than 0, which is this part right here. And we can simply write our final answer now that k is going to be greater and strictly greater than minus 4, yet in turn less than and strictly less than positive 6. So that now gives me the set of values.